Okay, today we're going to start out with a little bit of work on just solving proportions. Not a whole lot, but I just wanted to kind of, sorry, the microphone's slipping on me here. Sorry for that noise. Going to solve a couple of proportions, and I just want to go over a couple of them just for the sake of a little bit of an algebra review. So most of these are pretty good with. The ones that are going to get tricky are going to be the ones like, say, down here, number 6. Because we're going to start doing a lot more algebra work, and sometimes it's going to involve stuff like this. When I cross multiply here, I get x times x minus 4 equals 2 times 2x minus 6. When I distribute an x, notice I'm going to get an x squared minus 4x equals 4x minus 12. Now, when I get an x squared and an x in an equation like that, the only choice I have to solve this is to set it equal to 0 and then factor it, or use the quadratic formula or some other method. So I have to bring everything to one side of the equation. And I get x squared minus 8x plus 12 equals 0. Now we have to factor the polynomial. So I need to find two numbers just to remind you of the process. And this isn't part of your homework, but I want to just remind you of the process. I need to find two numbers that multiply or give me a product that's 12, because positive 12 here, and a sum of negative 8. I'm looking for those magic numbers. What two magic numbers give me a sum of negative 8 and a product of positive 12? Well, to get to 12, I have a few choices. It could be 1 times 12, or 2 times 6, or 3 times 4. Now, none of those give me a negative 8, but if they're both negative, the negative 2 times negative 6 gives me a negative 8. So my magic numbers are negative 2 and negative 6, and since there's not a number in front of the x squared, we can just go straight to factoring equals 0. And again, this is a review only just to kind of get your appetite going. We are going to see problems that require this in the future. And solving this, again, if I'm multiplying two values and the product is 0, that means either the x minus 2 equals 0 or the x minus 6 equals 0. So that means x equals 2 or x equals 6. So I just wanted to do that as a quick reminder at the beginning of the lesson here to show you again that, yeah, we do have some algebra that we're going to be running into over the course of this semester that's more than just linear algebra, it's quadratic algebra, and you're going to have to remember how to do that. So if you need additional help with some of these, please come see me before after school, testing center, or even ask during class. I'd be happy to help with that. All right, on to today's lesson. Triangle proportionality theorem. This works really nifty because what it does is it says if I have a line parallel to a side in a triangle, okay, these two are parallel, if that's the case, that the division of the sides is proportional. So QT over SU is the same as TR over UR, which is also the same, by the way, as QR over SR. It's all proportional. And conversely, if the proportion is true, then that segment here must be parallel. Then these must be parallel sides if those proportions are true. In other words, everything works exactly like you think it should in the picture. And everything will set up exactly the way you think it should. The biggest thing to remember is you have to think proportionally, not with a linear relationship, but with a proportional one. So very simply here, it says find the length of RQ. So whenever you're doing something like this, what I suggest is make sure you highlight what it is you're looking for so you know what you're looking for. Because I could ask for RU as well, but I just want RQ. And I just set up the proportion. I'm going to call that X right there for now. And the proportion is very simple. X over 4 equals exactly what you think it would be, 9 over 6. and we just cross multiply. 6x equals 36, so x equals 6. Now, we could also set this up by doing correspondence this way. I could take the x and the 9 and just do corresponding on this side would be the 4 and the 6. Notice when I cross multiply, I still get 6x equals 36. What did I do? I really just swapped the location of the 9 and the 4 in the equation, or in the proportion. Because we're cross multiplying, it works out pretty nifty. So the nice thing here is things work exactly as you would expect them to. That said, why don't you go ahead and find zy. Next it says determine whether these are parallel. Well, in order for them to be parallel, that means the proportions have to work out. And again, you just need to set it up and show that the proportion is true. Now, we could do like we did with side angle, side, and side, 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 and reduce the scale factor. But here, it's actually going to be easier just because I only have two things to compare. I can just set up and solve a proportion. So I want to check, does 90 over 72, does that equal, I'm not sure, the corresponding would be 50 over 40. And so we cross multiply. 90 times 40, 9 times 4 is 36. That's 36 and 2 zeros. 72 50s is also 3600. Oh, that is true. So that means that this is a true proportion, and these lines must be parallel. If the proportion winds up to not work out, then the lines are not parallel. It's that simple. The other way we could have done that is I could have taken 90 over 72 and reduced that. 9 goes into both those. That's 10 over 8 actually, and that reduces again to 5 over 4. And 50 over 40 reduces to 5 over 4. Both reduce to the same ratio. That's the scale factor. Boom, you're done. It's another way of doing it. So we could do it by just setting up a proportion and solving it, or we could do it like we did with side angle, side, and side, 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 and just reduce the corresponding ratios and see if they both reduce to the same factor. Three parallel lines, essentially the same thing. Basically what's happening here is with three parallel lines, instead of having a triangle with a parallel side, we're saying is basically, let's say there's another parallel side here, okay? And so we'll extend these lines a little bit, extend my parallel, whoop, now move it, extend it, come on, smartboard, and we'll just slide this side down, essentially. I'll have to extend this one to meet it now. Okay, so the proportionality still holds up, and it works out exactly the way you think it would. I mean, if I had some sides A, B, and C, and D here, A over B equals C over D, or if you choose A over C equals B over D, however you want to set that up. You get the same cross multiplying no matter what you do. Either way, you get AD equals BC when you cross multiply. So again, pretty straightforward to set up here. Notice it gives you all this information here, all the corresponding angles, which tells you the lines are parallel, and it tells you that this is 120, this is 150, this is 300, and it wants to know the distance between Main Street and 2nd Street. There's X. You need to set up and solve a proportion using these figures to do that. And again, the corresponding angles here tell you that these lines are parallel. So we can go ahead and set that up exactly the way you think it should set up.